Hello.
Shin.
Hi. Can you hear me all right?
Yes,
Hello.
perfect.
All right. Hi, Alida. How are you?
Very well, and yourself? Sorry, I just dropped
Hey,
my
good.
phone.
It's been quite a week, but a lot of learning. So Victor will be coming, right?
That I'm sending him a message now. He is online. Cool. I'm glad to see you could rearrange your schedule, Alida, to join us.
Yes.
So Alida, thanks a lot for joining. And I heard that you have taken up a new work, right?
Unfortunately, I have, yes.
Okay, but congratulations.
Thank you so much.
Yeah. So,
It's it.
Okay, Victor is online. All right. So I guess the idea to invite you here is to know a bit about what we're working with Victory here, okay, and see if there's any any place where you might be able to join to co-work as well, because right now the work we're looking ahead, I think it's more than doable by a person. So building up a team is what we're trying to do here. Yeah. So I guess maybe Herman can also maybe explain a bit about some of your ideas, I guess the ideas and expectations from coming from this inviting Alida here.
Yeah, so the idea with Alida's work is to look at that problem of the application where you've got the decentralized ride sharing, basically with the South African taxis. And you remember we spoke about that, I think, either a couple of weeks ago anyway. I think I sent the description of that. I posted that on Last First. But Alida will also be using some of the spatial pub sub. So I was thinking another place where Alida could help is with the actual implementation of some of the underlying routing and the spatial pub sub. I'm not sure how much time she has during the day, although it sounds like
So I have a lot of time during the day.
Oh,
an
great.
excessive
Wonderful.
amount of time. My
Okay,
biggest
great.
problem is just that I am technically at work, so it's a bit hard to like join meetings and stuff like that. I don't currently work on Mondays because of shifts and stuff. That's why I could join today. But I have a lot of time. I just don't have I just can't get into meetings like this. I mean, other than that, I don't do a lot.
Oh, okay, great.
Well, yeah.
Okay, and that sounds good. Actually, I mean, if you can just join meeting even I think once a week, that's good.
Yes.
And for the other times, we have everything recorded. Okay, so can catch up as well.
Yes.
And besides, I think there's also one positive thing about this, which is to get into asynchronous kind of work mode, which I believe is also going to be important. Working asynchronously. And we do have the video recording. So I think that's actually not a problem. Okay.
Okay.
All right. So great. So Victory has been. So Victory, you like to maybe get us updated on the latest part? And apologies for my mask, and I'm in the process of moving. Okay. So yeah, Victory, maybe you can update us a bit about the most recent progress. Okay.
All right.
And I'll switch off my video now. Okay.
All right. Hi, Alida. Thanks for joining.
Good morning.
I think we still have plans to meet later today.
Yes.
You have met before. Okay, great. Cool.
Yeah.
Awesome.
Person. All right. Let me just hide that. So I've been trying to play around with the spatial part. I wasn't able to meet with Aniju during the weekend. I think he had to do some work with some deadlines. But I was trying to play around with just getting the areas right in terms of. So I basically wrote the code in a bit separate. I didn't want to mess up with the main code. But the idea was to use this library called plot library. I think it's like a basic plot library. And the idea was to, let me see if I can open this quickly, to sort of mimic this, yes, where, yeah, or something like this, yeah, where you basically have nodes in this, the rectangle or the square is illustrated by a matcher region, and then you have nodes in that region defined by a radius, and you have this second matcher, and sorry, this matcher, and also different nodes in this matcher area, and you have maybe this third node where perhaps it's sort of in between, and the idea is to connect to the matcher with the what's the word that covers, that the node covers the most range, basically, at least in theory, and to sort of show that in like a x1 x2, like basically an xy plane, and to just show sort of create that or recreate that in Python. And basically it's like a simple stuff. I created the coordinates here. So here is the position at which the matcher starts, 0, 0, and you have the dimensions of the matcher area or matcher region, which is 120. The length is 120. You'll see that, as well as the height to be 100. Same one, we did that for two matchers. That's why one is illustrated with blue and red. And the simple, should I say, the idea was to, okay, yes, and then the node, sorry, the node is defined here with, it has the coordinates and it has the radius, right? And the same thing with node 2, which is here, coordinates and a bigger radius. And basically the whole execution here is to sort of plot all of that, and there's this library that allows you to sort of patch shapes into that. So, well, we created matcher 1, matcher 2. This is just setting up the colors. This is using the variables we created earlier, and basically this is just scales up the drawing to show everything. And here in this slightly, and I'm not sure if there's a better way around this, but the idea now is to say, if node 1 is in this region, which is something we defined here earlier, I think that should be 0. But if it's in this region, sorry, it's here. Sorry, I meant here. Where you have that, then basically just say you found the match in area 1, else print no match. And if the second coordinate, or sorry, the N2 coordinates is found in this region. Now, if you notice, this is like double the length, which is to say 0. And that's why I think there's probably a more efficient way to do this. But the idea is 240. You have 0 to 240. And if it finds something between 240 and, in the range 240, 100, which is length and breadth, then you're basically saying print, show that there's a match found. Basically, that's the matching process from the way I'm thinking about it. And basically, if you run this, there's basically a match. And I think if I make this 500, it should show that there's no match. Just for example, that's not right. Let's see, something is wrong. Sorry. Okay, something is off there. I don't know what that is. I'm guessing it's because, okay, I'm not sure. But the what I'm trying to now accomplish is I'm trying to see if there's a way to make this into an edge. So yes, this has been plot, but to sort of do some sort of edge detection, there is a code that I've sort of found. Well, it's an HTML code though that allows this. I don't know if you've played this Tetris game. That I think those games are sort of designed in that manner where you have edges around the screen, and the idea is these nodes can move around the edges and sort of hit the corner. So I think with the edge detection, if that is right, then the edge can be defined better. If that makes sense. It can be what's the word now? It can be it can sort of be referenced in terms of, okay, if edge 1 or edge 2, or if the radius hits, or sorry, the edge of the circle hits the edge, then something happens, basically set a flag. And the idea is now to implement that, once this is right, to sort of implement that into the main. Sorry, I'm using so many environments. I couldn't plot in Visual Studio Code for some reason. But in the simulator, that's where we can now specify the radius, the area, and that kind of stuff. But I think the major thing that will change here is now to sort of specify this. So here, for example, we just and that is something also I think we spoke about last Thursday with Chenyan. That to sort of decide where the best place is to initialize what mode, whether it's spatial pub or standard or channel based pub sub. And I think it's better to initialize that in here, where we are saying, okay, this is the matcher, this is the ID, and this is the mode I'm activating. So spatial sub or spatial pub, or channel pub sub or spatial pub sub. And at the node layer, then we can define the radius, or so we have a node, but that's defined by so the radius should sort of be defined here, and not necessarily in this section. But yeah, I think that's more or less the major updates. In terms of the documentation, I think we've been playing around with that. Nothing much has happened since I think I met Shenyun last week, but the idea is to sort of build on this as well. I'm not sure if Professor Hammond already saw this section. I think he already did, but we're sort of putting in populating this this section with like little by little information, and I think I should be able to get a bit more done on the writing part of this section. Are there any questions?
Okay, all right, Harman, would you like to provide feedback?
So you're busy implementing the spatial area overlap. That's basically what
Yes.
you're doing at the moment.
Yes.
Okay.
Yes.
So there, what you can do is you can look at some computational geometry algorithms. There's specifically one which is called the point in polygon, which is problem, which is basically if you want to determine if a point is inside a polygon or not. So you can define your region, which is a square, you can define as a polygon. And then there's a number of algorithms which are efficient in determining if you're inside a polygon or not. Yeah, you might even find some of these algorithms already implemented in some libraries. I'm not sure, but they're not difficult to implement. But that's a general way that you can use to determine if a point is inside a polygon or not. And then you also get some algorithms for determining if polygons overlap with each other. They're slightly more fun. But yeah, that you'll find basically in computational geometry. And there's I think a lot of work in GIS also looks at, points inside polygons and polygons overlapping and things like that. Yeah, so there's a fair number of algorithms out there that you can look at that will help you do this. And I mean, you could probably look at convex polygons, or they're sometimes called simple polygons, because in a Voronoi, if we're looking at Voronoi diagrams, they typically are simple or convex polygons. If you want to be as general as possible, then obviously you must be able to handle any type of polygon. But I guess for now, it's fine if you just look at convex polygons. So you're basically trying to build the spatial part of the spatial pub subrouting. That's what you're doing now.
Yes. So just to confirm, I did consider the polygons, because I have seen stuff like that. I think I saw someone even do it a couple of months ago. But there was a sense of complexity in terms of I don't know, I'm not very familiar with the field. That's probably why. But I do remember, for example, there's a sense of in terms of the computation part. Uh, wouldn't that require like resources in terms of? I mean, okay, in terms of speed now, I'm not really sure how efficient is the Polygon approach.
Well, I don't think that's of concern. It's
Oh, okay.
modern machines are too fast anyway. With the amount we're calculating, it's piece of cake.
Yeah.
It won't be a problem until you really scale up to, really, really large number, like
Yeah.
tens and
basically,
hundreds
yeah.
of thousands. Yeah.
Okay. Okay. That's fine. Makes sense. All right. Thanks, sir.
Okay. So yeah, so if I understand, then you're basically now implementing you've got the channel-based PubSub now. It's working for at least one matcher. And
Yes.
then what you're doing now is you're doing well, okay, there's two parts here. The one part is when your publication area or your subscription area is wholly inside one of the matchers area. Then it's basically about determining that that's inside that area and then taking the appropriate actions when you receive a subscription message or a publication message.
Yeah.
And I think last Wednesday we spoke about that you should just focus on that case where you have one matcher or, and it's wholly within the one matcher's area. That second case that you have over there with a publication or a subscription area overlapping more than one, that is the more complex case, but I would not solve both of them at the same time. I would first focus on the simpler problem and then make certain that's working correctly, and then figure out how you want to handle the case where you've got, overlapping more than one area and how you're going to handle that.
Okay.
So
yeah.
Sorry.
Yeah, I would be careful of hard coding if you just want to get something working and check that it's working, it's fine. But I would be careful of hard coding areas inside the code. Okay, but it is an example code that you have over there. If it helps you get working, yes. But I think you want to replace that with a general type of algorithm where you can say, here's a point, here's an area, do they overlap, yes or no? Is the point inside the area, yes or no? And the same with here's two areas, do they overlap with each other, yes or no? Because that's going to be the building blocks of, it's the same question of, am I subscribed to this channel? That is, the answer is the same as, do these two areas overlap?
Okay. So it's more like, so we designed more like a black box where you simply just plug in any variables and you should execute the same thing for any.
From the point of view of the nodes, yes.
Okay.
Yeah, I guess.
Okay.
Yeah.
All right.
Okay. All right. So Victor, I can see that you're trying to do some coordinate comparison, right? At line 44 and 50. Are those like coordinate comparisons to see if one is smaller than the other in terms of XY?
Yeah, precise. So the idea was to sort of check if this coordinates is, less than the defined matcher coordinates, which is, that.
I see. Okay.
The better way, or should I say the more efficient way, in my opinion, would have been to put this in a bit of like a tuple or something. But this library doesn't allow tuples. It has to literally be that M1. It has to be put in manually, like one by one. It's only the position that allows for tuples. Then that's why I really do think there has to be a better way. I'll look into the polygons.
Okay.
Yeah.
Actually, all right. I think we don't have to really look at polygonal for now. Maybe just choose one, like circle, rectangle, might be easier. Just to work with I mean, for publication and subscription, I think circles will be enough.
Yeah.
Okay.
Yeah.
And it's only when you are checking whether a node belongs to a certain matcher's managing region. Okay, then because the matcher might be partitioned in some rectangular way for now. Okay, what we really want to do is actually Voronoi partitioning in the future. Okay,
Yes.
for what matchers are managing. So you have
Yes.
to realize that it has to be general enough. You know, it's kind of
Okay.
like what Herman was saying. You are just doing an overlap test. Okay, for
Okay.
example, of this node against that matcher, something like that. And how it's actually been done, you know, that the underlying will actually take care of itself. Okay, so on the high level, you're calling the same kind of functions, okay, such as an overlap test. But beneath that, whether you are using rectangular for matchers region or Voronoi, okay, or some other shapes, like there's also hexagonal. You can also use hexagons to do space partitioning, okay, if you are, or quad tree, right? Then
Yeah.
that would change on the implementation. All right, so I guess
Okay.
that's just a high level, I guess, view. All right, I think the time that we have, maybe it's helpful to discuss a bit about how Alida might be able to help, okay, and
Okay.
to sort of join into the current effort. So I think with that, maybe you can ask Alida about like what do you think? I guess your interests and maybe some of the capability are okay regarding this project, and are there specific areas you might be interested? Okay, and I guess the sort of high level view, we talked about this I think last time, and I don't know if Herman has discussed more about, but essentially we're trying to build up an open source implementation that can support spatial PubSub for applications such as Uber, okay, such as a decentralized version of Uber, okay? That, does that
Yeah.
make sense? I guess just
Yes,
from
yeah.
sort of a high level, okay? So you
For the
can
yeah.
imagine Uber has certain system and architecture, right? That supports its application, but it's close, it's proprietary. Okay, if there's another company or startup that wants to use or leverage, or you know, Google Maps for that matter, it's you can only use maybe at API level, but not much beneath that, right? So
Yeah.
the idea is whether we can provide a you know sort of an open alternative to what they may currently have already, but in a more not just open, but also more, I would say, sort of like providing some primitives, because spatial PubSub, if realized, it can support not just like Uber, but also like online games, virtual worlds, you know, LBS applications, all kind of things. Okay, so does that make sense?
Yeah, 100%.
Okay, all right. So I mean, what would you like to get involved, or where do you think you can make the best contribution in this? Do you have any thoughts?
I went through the document Arman sent that basically outlines it and describes it. And obviously, I'm still a bit inexperienced and behind, considering I haven't really, I've done the research, but not really much. But the part I would like to help in, or the reason why I would want to do this is because I enjoy programming, especially in Python.
Oh, really?
So,
Nice.
yes.
That's excellent.
Wow.
So,
Okay.
Wow, you got a
uh,
Python expert.
Yeah, that's great news.
I wouldn't say expert.
Well,
So it's
But
you're
yeah,
definitely
superstar,
more an expert than I am. I'm sure.
and me as well, most likely.
yeah. So time will tell. So that is the part where I would have, well, where I started to look at that. I kind of have a skill set for already. I was,
Okay, nice.
yeah.
Okay, all right, okay. So I think maybe I guess let's talk about Victory first. Okay. I think for Victory, I mean, the current implementation, I think what needs to happen is we need to see a actual case of spatial PubSub working, okay, with a single matcher, all right?
Yeah.
So actually, I mean, I know you're doing some kind of overlap tests, that which is okay. But what we want, I think, for this purpose is actually overlap tests between a publication area and subscription area. Okay, actually not against the matcher's rectangular region. You see? That makes sense? So the overlap test you might need to support is actually to check if two circles overlap. You know, one being a subscribe circle, one being a published circle.
Mm.
Okay, does that make sense?
Sorry, Shunyan,
Oh.
just to confirm, so for what are you saying? Okay, okay, sorry, never mind.
You get it?
I was overthinking.
I mean,
yes, I was
yeah,
thinking
okay.
each node can publish or subscribe, and they are just
Yes,
making
yes,
requests.
yes.
And them, yeah,
I
sorry.
mean, to make things
Yes,
simpler, I would suggest we focus and limit ourselves only on, circular subscription and publication, okay? Because then it's defined only by a center point and a radius,
Yeah.
okay? And the
Yeah.
overlap test should be simpler in that case,
Okay.
okay? So, I mean, and because for matchers, the partitioning, really depends on the partitioning. Okay, right now we might use rectangular for tests, but that is something that certainly will gets to change as we move to things like Voronoi partitioning. Okay.
Okay.
But,
So you
but
can
the
think
overlap-
about you have
Okay, Armin, go
yeah
ahead.
you can think about you have one matcher and you have one rectangular area, and that basically just defines the area in which publication and subscriptions will take place. But
Yeah.
then you will need to have someone subscribing to receive messages in an area, and your matcher must keep a record of that. And then you must have someone trying to publish in an area, and then some of those areas will overlap, and sometimes they won't. The publication and the subscription areas won't overlap, and then your matcher must correctly determine when they overlap, who must receive the publications, and when they don't overlap, also so that would be a case of, if the big circle is the publication area and the small circle is a subscription area, then if someone publishes in that publication area, the matcher will not send the message onto the subscriber. But if they were overlapping, the matcher would need to determine that and then say, okay, this message needs to be, forwarded to everyone whose subscription area overlaps with the publication area. Yeah, I think
Okay.
that nearly overlaps now. But anyway,
All right.
that's just an example.
Okay. So, so is that clear, Victory? Or
Yeah, no, it is clear. The thing is, I'm trying to see the matcher role in this case. Then, I mean,
okay,
from
you
my
can assume the matcher
yeah.
has a full, of the whole space.
So the matcher knows what's overlapping and what's not. Basically.
Well, right now we can just assume that all the nodes are managed by a single matcher for now.
Yes.
Okay, so you don't worry about the overlap test between the matcher and any of the nodes for now.
Okay.
Yeah.
Okay.
Yeah.
See?
Okay.
Right now, just make sure the matcher can help a published node to find, relevant subscription area and send forward the message to it.
Okay.
Right now, that's all that matters.
Okay. Yeah.
Because remember, the subscriber, when it wants to subscribe to an area, it's going to send a subscription message to the matcher, right?
Yeah.
And when a publisher wants to publish, it's going to send its publication message to the matcher. The matcher is then going to determine what to do with these messages. So in that sense, the matcher will know whose areas overlap, whose publication, and what are the publication areas and what are the subscription areas.
Okay.
Okay, all right, good. So I guess for Alida, I think what my sort of a small exercise I'm thinking is perhaps you can help to write some I guess objects or in Python that supports rectangular and circular shapes. Okay, and then also overlap tests between them. Does that make sense?
Yes.
So,
understand.
so basically this can be used, in later, if it's done, sort of Victory can just use that. Okay, and to support more kind of shapes, so to speak. Okay,
Okay.
okay. And basically just leveraging and basically make sure you can define shapes and then you can do overlap tests between any two shapes. Okay, and right now I think just support circle and rectangle. That should be enough. Okay,
Yes.
that should be small enough, right? To
Yeah.
get started.
So Alida is in Stellenbosch today. So I just so I'm gonna be meeting with her later today as well.
Okay.
Just yeah.
And then I think we can from sort of evolve like what kind of research topic. Okay,
Yes.
I could also like work on,
Yeah.
because some of these definitely has to be sort of related to your master in the
Yeah.
upcoming
Yeah,
weeks, right?
yeah.
In the future. Yeah. All right. So is that okay for both Victoria and Alida?
Yeah.
Very good.
Okay. All right. Good. So I'm thinking that if possible, Alida can also maybe do a daily update of your progress. And this is something I think this is on Slack, yes. And perhaps if needed, then maybe also a some sync between you and Victory. But I think for the time being, we can just start with text sync for now. And if you have any sort of updates, make sure Victory see that, so Victory can maybe also update during our regular sync like this time. And if there's any new assignment, I will be speaking in the sync. And Victoria also make sure Alida knows that if there's any new assignments. Okay. Yeah,
Okay.
because right now Alida can only join us once a week, right? On Monday
Yeah.
now. Okay. So let's try this. What do you guys think?
Exciting.
That
stuff.
sounds perfect.
Okay. All right. So Herman, is that all right?
Yeah, that's good with me.
Okay. Okay. All right. So welcome, Alida, and thanks very
Thank you
much,
so much.
for the joining, and hope this is going to be more and more exciting project for all of us. Okay. All right.
I hope so
Okay.
too.
All right. So yeah, talk to Victoria and Herman tomorrow.
Tomorrow morning.
All right. We'll see tomorrow. Yeah. All right. Okay. Yeah. Bye bye.
Thanks, everyone.
Yeah. Bye bye.
Goodbye.
Yeah. Bye.